That posting wasn't a mistake. It was accidentally honest. Building AI agents that actually work in production demands system design, tool integration, security, and orchestration all at once. Think of it like this. Anyone can follow a recipe, but a chef understands ingredients, timing, workflow, and how to improvise when things go wrong. Prompting is the recipe. Agent engineering is being the chef. And most companies are hiring line cooks expecting a Michelin star kitchen. By the end of this breakdown, you'll know exactly where your team stands. What makes this so painful is the discovery phase. The first 2 months feel productive. Your team spins up prototypes, demos look impressive, leadership gets excited. But building an agent isn't building a chatbot. It's orchestrating an entire system. Databases storing state, multiple models coordinating decisions, tools executing real actions in the real world. That complexity doesn't show up in a demo. It shows up when you try to make it reliable. And by the time the team admits they need help, you're not just paying a vendor. You're paying a vendor plus everything you already spent trying to do it yourself. Think of this like a restaurant kitchen. The source material nails the analogy. A chef doesn't just follow recipes. They understand ingredients, timing, workflow, and how to improvise when something burns. Building AI agents works the same way. Each row on that scorecard represents a different station in the kitchen. System design, tool contracts, security, orchestration. Skip even one, and the whole service falls apart. A job posting that kicked off this video listed 5 specialties for one hire. That's not a typo. It's the reality of what production agents demand. Most teams discover which stations are empty around month 3, after they've already committed the budget. Most back-end engineers already have a head start here and don't even realize it. If you've ever designed a system where multiple services talk to each other, microservices, event queues, load balancers, you already speak this language. Agents work the same way. Data flows in, decisions get made, actions fire off, results come back. The difference is that your orchestrator isn't deterministic code anymore. It's a language model that can surprise you. That's where contracts become life or death. Every tool your agent calls is essentially a promise. Give me this specific input, and I guarantee this specific output. When that promise is tight and explicit, things work beautifully. But when it's vague, when a tool description says something like processes data without specifying what shape that data needs to be, the agent starts guessing. And a guessing agent in production isn't creative, it's dangerous. Here's what actually breaks in the real world. The agent calls a tool with the wrong input format. The tool doesn't crash, it returns something unexpected. The agent takes that unexpected result and feeds it into the next tool. Now you've got corrupted data flowing through your entire pipeline, and the failure doesn't surface until 3 steps later. By then, good luck debugging it. This is why the chef analogy matters so much. Anyone can follow a recipe that's prompting, but knowing which tools to reach for, what temperature the oven actually runs at, and what to do when the sauce breaks? That's engineering. That's the gap most teams don't see until they're already 3 months into a build. These 3 skills are where most teams hit the wall. Not at month 1, but at month 3. Here's why they're connected. Your agent talks to Stripe to process a payment. That API call fails. Without retry logic and fallback design, your agent just silently lost someone's money. Now multiply that across every external service your agent touches. Databases, calendars, search engines, payment processors. Each one is a potential failure point, and failures cascade. One bad response poisons the next decision your agent makes. The pipeline problem is just as brutal. You've got a model that worked great in testing. You deploy it. 2 weeks later, user behavior shifts, and your model starts making worse decisions. That's called drift. And without automated monitoring, nobody even notices until customers start complaining. You need systems that catch performance drops, roll back to the last good version, and retrain, all without a human babysitting the process. But security is the one that keeps engineering leads up at night. A chatbot that gives wrong answers is embarrassing. An agent that takes unauthorized actions is dangerous. We're talking about software that can send emails, modify databases, and trigger real transactions. Without hard permission boundaries, one hallucination doesn't just produce a bad paragraph, it executes a bad decision. And unlike a typo, you can't just hit undo on a wire transfer. Every demo is a controlled environment. You pick the inputs. You know the happy path. You've rehearsed the flow. And it works beautifully every single time. But production doesn't follow your script. Real users type things you never imagined. They hit edge cases at 2 in the morning that your team never tested. They chain 3 actions together in ways that break your agent's logic completely. This is where product thinking separates toys from tools. Chef doesn't just know how to cook one dish perfectly for a food critic. A chef designs a menu that works during a Friday night rush, with substitutions, allergies, and a broken oven. Product thinking is that same discipline applied to agents. Deciding what your agent should refuse to do is just as important as what it can do. And then there's the evaluation gap. Most teams test their agent the way they'd test a demo. A handful of examples, maybe 20 or 30, but agents that take real actions in the real world need the same rigor you'd give a deployment pipeline. You need adversarial inputs, the weird stuff, the malicious stuff, the stuff that makes your agent hallucinate a refund policy that doesn't exist. This is exactly where that month-3 wall hits hardest. Teams discover their agent works on the 10 scenarios they planned for, and breaks on the 1,000 they didn't. By then, they've already promised the board a ship date. What the matrix doesn't show you is the third option nobody plans for: paying for both. That job posting asking for 5 specialties in one person? Multiply that by 4. That's your build team. And those engineers don't just need to exist, they need to already speak each other's language. System design, tool contracts, orchestration, security, all overlapping inside the same small group. Finding even one of those people takes months. Finding 4 who work well together? That's a recruiting miracle. So what actually happens? Teams pick, build. They staff up, start strong, then hit the skill gap around month 3. Suddenly the orchestration layer is brittle, the tool contracts are vague, and nobody owns the failure modes. The board starts asking for a timeline, and here's where it gets expensive. You pivot to buying, but you don't get those months back. You don't get that budget back. You've paid the build price and the buy price. That's the cost spiral. Now flip it. Buying gets you live in weeks, sure. But every workflow runs through someone else's architecture. When your competitors build a custom agent that handles edge cases yours can't, that gap compounds every quarter. The vendor won't customize for you. You're one of 10,000 customers, so neither column on that screen is wrong. The trap is choosing build without the roster to back it up, or choosing buy without accepting the ceiling that comes with it. The honest answer starts with that scorecard from earlier. Below 8 out of 14, the math says buy. Above it, building becomes a real option, not a gamble. Here's what that number really means in practice. Most teams we've studied don't score a clean 0 or 14. They cluster around 5 or 6 strong on back-end architecture, weak on evaluation and security. And that gap isn't something you close with a weekend workshop. Remember that job posting from the beginning? 5 specialties, 1 hire. If your team is missing 3 or 4 of those skills, you're not months away from building a production agent. You're a whole hiring cycle away. Maybe 2. And every month you spend trying to build while underskilled is a month your competitors spend shipping with an off-the-shelf tool that works today. The exception on screen is real, but it's narrower than people think. 18 months of runway sounds generous, until you factor in recruiting timelines for people who understand both distributed systems and ML operations simultaneously. Those candidates are rare and expensive. So before you chase the exception, ask one honest question. Does your organization actually have the patience to let a team struggle for a year before seeing results? If the answer is anything less than an enthusiastic yes, the scoreboard already made your decision.